All right. I think we can begin. So, hi, welcome back to another session of Flashmath. Today, we're going to be talking about something that might be a little bit out of the scope for AMC10, but it's very handy for AMC12 and for the AME as well. So I promise it's going to be logarithms. We're going to go pretty slowly. Please let Andy or me know if you have any questions. And yeah, let's get started. All right, hopefully everyone can see my screen. So first, here are the answers for the homework about algebraic manipulations. I'll just leave this up for a couple minutes. All right, let's get started on. Okay, so first let's review some basic logs, exponent rules, since exponents and logs are very, very closely related. So let's see. We have, if you have if you have x to the a times x to the b, you get x a plus b. You have x over a, x over x to the a over x to the b. The result is going to be x to the a minus b. And then if you have x to the a to the power of b, you have x to the ab, x to the negative a, so 1 over x to the a. There are just some basic exponent rules you should definitely familiarize yourself with before we get into logarithms, and they translate directly into some very important logarithmic identities. So what the heck is a log? You can think of it as like a reverse of exponents. So I'll write out log a. Okay, actually, if we have a to the x is equal to b, let's say that we have this equation, and we want to find what x is in terms of a and b. We can do this. Log base a, that's what the subscript means. Log base a of b is equal to x. It's a way to find the exponent with using the base and the result, I guess you could call it. Most of the time, we will use logs in base 10. If you see log 5, then with no base, no subscript, that'll just be log base 10. So log 5 is going to be the number where 10 to the log 5 gets you 5. If it's not base 10, we'll say log 2 or log 3 or whatever base you're using. You can use whatever base you want. There is one exception to this, and that's if the base is the constant e. If you don't know what e is, don't worry about it too much. We won't talk too much about it. In which case, you'll call it ln, or natural log. It doesn't appear much in contests. I might go over like one question that includes this, but it's really, really handy if you're doing something like calculus, you probably don't have to worry about that now. So let's just get a little bit of practice before we move on to like basic identities. Log base 5 of 125. It's 3 because 5 to the 3 is 125. Log 1,000. Oh, actually, log 10,000. Well, there's no base, which means that that base is going to be base 10. So we want to know 10 to the power of what gets you 10,000? And that would be 4. Then let's do one more. Log to 1,024. So 2 to the power of 10 gets you 1024. So this one is going to be 10. Actually, I'll do one more example just because I realized I didn't go into some more nuanced examples. So let's do log base 4 of 1. Well, we know that 4 to the power of 0 gets you 1, or anything to the power of 0 gets you 1. Except for maybe 0, but that's a very weird example. So log anything gets you 0. By the way, the log function isn't defined if the thing that you're taking the log of is negative or 0. And then one more example. Log base 5 of 1 over 25. That's going to be -2. So the result that you can get can't be negative because 5 to the power of -2 is 1 over 25. So here are some basic identities. First one, log, if all of these, we're gonna say they have to have the same base in order for this to work. You can't mix and match. You can't do log base 2 5 plus log base 6 of 7. You can't do that. You won't get anything of that. You can add them, but you can't get anything from them. But if they have the same base, that you can combine them into a product within. So like we have log 2 plus log 5, then our result is log 10 because that's 2 times 5. And because we're in base 10, that ends up getting you 1. So this is definitely very handy. Definitely don't mix it up with like log x times log y, though. That one can't be evaluated. Next, this one's basically a reverse of this, but if you're subtracting logs from each other, then you get log with the same base, then you get log x over y. Log of a power. So if you have log base 11 of 2 to the 3, that, which is 8, you can turn that into 3 log that. There's this one, power of a log. You can swap these two if you're raising something to the power of a log. Change of base, lastly, this one is a little tricky, but it is probably the most handy out of all of these. Like it single-handedly breaks a lot of AMC12 questions. If you have a base that you're not too good with working with, like base B, you can change it to a different base. D would probably be 10 if you wanted it to, but like anything really works. And it depends on the question, but you can turn this, you can put this on the top and then have that. So something like log base 2 of 11, you can turn it into log 11 over log 2, which can be really, really handy. So I'll leave these up for a bit because if you want to write them down somewhere, they're very, definitely want to know these like the back of your hand. So let's get started with our first. Let's try just some practice with all of these formulas and stuff. So log 5, 8 minus log 5, 4. How about that? So that would be log base 5, 8 over 4, which would just be log base 5, 2. Now let's try something with like a little bit of algebra in it. Log 6x, no, we're going to be in base 10 for this, minus log 4 minus x is equal to 3. Actually, you know what, I'll change this one a bit. I think, okay, sorry, this question is a bit better. So this one, we can turn it into log 6x over 3, which is log 2x, which is equal to 3. Then we know that 10 to the 3 is equal to 2x. And then that's just 1,000, so x is equal to 500. Let's do one more. Log x is equal to 2 minus log x minus 21. We've got a couple ways we can approach this. Either we can move all the logs to one side, like this. Or we can just turn the 2 into log x. And then, okay, for this one, you end up with this. And for this one, you end up with log x, log 100 minus log x minus 21. And then you can simplify that with identities that we learned. Either way, you end up with the same thing. In this case, you have x times x minus 21 is equal to 100. And in this case, you get x is equal to 100 over x minus 21, which same thing. You can do either way. So you have x times x minus 21 is equal to 100. Let's expand this. Pretty typical quadratic. We can factor it. Now what we want to do is plug it back in to make sure it works. So we have 25 log 25 is equal to 2 minus log 4. Sure, there's nothing undefined in there, so it works. But the problem with -4 is that we have log -4 is equal to 2 minus log -25. You can't take the log of a negative. So -4 doesn't work. There's only one answer, and that's just 25. All right, now let's get let's do some actual questions. So let's try this one first. All right, let's try this. So this one is a question where the change of base formula is really handy. Since there's no other, since I'm not sure if there's really any other way to simplify this, but so in this case, let's have log base 2 of a. We can turn that into log a over log 2. The choice of base doesn't matter too much. So now we can put all of these back in, and the reciprocal of this is log 2 over log a. This one is log 3 over log a. And then this is log 4 over log a. It's equal to 1. So we can combine that all into one fraction since they have the same denominator. And then this top one can be simplified with the product identity. Basically, when you add logs, you multiply these. So you have log 24, 2 times 3 times 4 is equal to log a. So a is equal to 24. Try this one out. Okay, this one can be, so first of all, we have no idea how to, so first of all, we don't know quite how to get that 7 to the 7, but if you remember the exponent rules that we introduced at the beginning, this can be expressed as 7 to the x times 7 to the 7 is equal to 8 to the x. It's really handy because we want something to the power of x, so that when we take the log, we can just end up with an expression with x. So we can divide both sides by 7 to the x. We have 7 to the 7 is equal to 8 over x over 7 to the x, which actually can just be written as this. Then we can take the log of both sides, and the log of choice will make the log base of choice will just make it 8 over 7, so that our left side can just our right side can just be x. So x log 8 over 7 to the 7. So that's our value of b. Okay, now let's try this one. Okay, let's try this one. So first, it's probably a good idea to, let's see if we can change everything to log base 2. So that sounds like a bit of a daunting task, but I'll walk you through. First of all, let's change this one to log base 2. We can turn that into log base 2 of n and log base 2 of 16, which is just 1/4 log 2n, since this is just 4. So on the left-hand side, we have log base 2 of 1/4 log base 2n. Now let's deal with the right-hand side. So I'll just cut this and move it. So first, let's deal with the outermost log. So we have log base 2. Actually, let's deal with the innermost one. I'm dumb. So log base 4 of n. We can change base to log base 2 of n and log base 2 of 4. This is just 2. So our result is log base 2, 1/2 log base 2 of n. Then we can take this outermost thing, log base 4 of 1/2 log base 2 of n, change base to log 2. And that just becomes 2. So yeah, 1/2 log base, I'm getting very cramped. Log base 2 of 1/2 log base 2 of n. So we have two expressions, one on each side. So we have log 2 of 1/4 log base 2 of n. And we have 1/2 log 2, 1/2 log 2n. Messy problem, well, messy expression, but let's see if we can do anything with it. We can turn this, knowing that log AB is equal to log A plus log B. We have that. We can use that identity to our advantage here. We can turn this into log 2 of 1/4 plus log 2 of log 2n. By the way, you can't stack logs. Like you can't turn this into like log base 4 of anything. This just stays as it is. Is equal to 1/2 of log 2 1/2 plus log 2 of log 2n. So a couple of these values we actually do know. Like this one is just -2. We have this messy log 2n. The good thing is we have this on the other side, so we can just solve for this thing, treat it kind of like a variable. We can even substitute if the logs are really annoying, but I don't think they are. This one's just -1, so we have 1/2 times -1 plus log 2 log 2n. Let's move this to the other, let's move this over here and this over here. We have log 2, or 1/2 log 2 log 2n is equal to 3/2. Now we can multiply both sides by 2 to get log 2 of log 2n is equal to 3. So 2 to the power of 3 is equal to log 2n. So that's equal to 8. Then we have 2 to the 8 is equal to n. So n is just equal to 256. Our original question was asking for the sum of the digits of n. That's just 2 plus 5 plus 6. That turns into 13. It's kind of a mess, but making sure you know when and where to apply some log identities will help you a lot with this sort of question. And as always, feel free to ask questions. All right, let's move on to the next question. This one was on this year's Amy, but I think it's reasonably doable. Okay, let's try this one out. So we want to find what the common ratio is, and this thing looks kind of ugly, but these two look relatively neat, so let's try focusing on those two first. If you remember what a geometric regression is, it's basically a sequence AR squared. You multiply the same thing as you go from term to term. So to find the common ratio, let's see if we can evaluate log 2x and log base 4 of x. The handy thing with this is that change of base like completely breaks it. We can turn it to log base 2 really. The top just becomes log base 2 of x. The bottom, when we turn it into log 2, gets you log 2 of x, log base 2 of 4, and this thing is just 2. Meanwhile, these are the same, so we can cancel them, leaving us with 1 over 1/2, and that's just 2. So our common ratio is 2, which is definitely a really good start. Now let's see, 2 times log base 8 of 2x is equal to log base 4 of x. Let's turn all of this to log base 2 because we definitely can't combine 8 and 4, but they at least have log, they're both powers of 2. So we can turn this into 2 times log base 2 of 2 of x over log base 2 of 8, that's 3, and then log base 2 of x and log base 2 of 4. We can quickly replace these with 3 and 2 respectively. And then this thing we can split into log base 2 of 2 plus log base 2 of x, and then this is just 1. So we have 2 times 1 plus log 2x over 3 is equal to 1/2 log 2x. We can go ahead and evaluate that. That's 2/3 plus 2/3 log 2x is equal to 1/2 log 2x. Negative 1/6 log 2x is equal to 2/3. So log 2 of x is equal to -4, and x is equal to 1/16. That's 2 to the -4. So to find the actual answer of it, the number of x can be written as m over n. That's 1/16, so 1 plus 16 is 17. That's our answer. We've got 2 more questions to go, but sort of limited time. So I might have to speed up a little bit for these 2. You can watch like the video after class if you missed something. But I'll leave like a couple minutes for each. All right, so let's take, so to find a, b, c, d, we should probably take the log to isolate them. So a is equal to log base 4 of 5, b is log base 5 of 6, c is log base 6 of 7, and d is log base 7 of 8. So when we multiply all these together, we can, so a, b, c, d turns into log base 4 of 5, log base 5 of 6, log base 6 of 7, and log base 7 of 8. And then with change of base, we can just, we'll write them as log base 5, log base 4, log base 6, log base 5, log 6 over log 5, log 7 over log 6, log 8 over log 7. Which we can cancel a lot of the terms. So we end up with log 8 over log 4. To further simplify this, we can turn it into 3 log 2 and 2 log 2, because that's 2 to the 3 and that's 2 to the 2. And then the log 2's just cancel. So we end up with 3/2. One more question, and this one's rather difficult actually, but give it your best shot. All right, so this one is definitely pretty tricky. So what we want to do is we want to, these two are of different bases. Let's see if we can make them the same at least. So this one becomes log x over log n, and this one's log x over log m. Then we have 8 log n log m times log x squared minus this one becomes 7 log n plus 6 log m log x minus 2013 is equal to 0. Make sure you know what the question is asking for in this case, because here they're asking for the product of the solutions for x. And the thing with the product of the solutions, let's say that the solutions for x would be x1, x2. and then we want to find the product for that. What we could do is we could take the log, since everything is in terms of log x, if we have log x1 plus log x2, and we add them together, that gets us the log x1, x2, and that's what we want. So even though that this is an equation for log x, there is still a way to find the product of the solutions for x, and that is by using Vieta's to find the sum of the logarithmic solutions. So in this case, sum of the values, so the sum of the roots of this equation would be log 7 over log n plus 6 over log m over the coefficient here. Notice that we don't have a negative sign because this is already negative. We can multiply the numerator and denominator by log n log m to get this. By log rules, we can turn that into log m to the 7 plus log n to the 6th over 8 log m7 n6 over 8. So that's just log the 8th root of m7 n to 6. That's because this is basically 1/8 log m7 n6, and then we're raising this to the power of 1/8. So we want to make this the smallest integer possible, given that m and n are integers greater than 1. Since we're running a bit over time, the smallest possible solutions for these, you want to find something that has like a common base power, a common base. So if we have m is 2 to the 2nd, we have n is equal to 2 to the 3rd, then you put those in, you get 2 to the 14th plus 2 to the power of 18, or not plus, but times, which ends up being 2 to the 4th. So that gives us an integer, which is what we want, because the product of solutions for x is an integer. In that case, our answer is m plus n, which is these two, 4 plus 8. That gets us 12. So that's all of the log problems for today. This last one was definitely very, very challenging, but you guys can, but hopefully made some amount of sense. Even if it didn't, then hopefully you followed along with the other ones. Definitely get some practice with the homework this week, and I'll pass it along to Andy now.